Okay, so 6.6 is all about the quadratic formula. All we are doing in this lesson is plugging things into the quadratic formula to find our zeros. The quadratic formula, find a pin, can find the zeros of any quadratic. So the quadratic formula can find the zeros of any quadratic. So some quadratics we can solve out using the square root method. Some quadratics we can find the zeros by factoring. But the quadratic formula works for every single quadratic. So if you are stuck when you are trying to factor, you could always stop and use the quadratic formula instead. It works for any quadratic. This is our quadratic formula. It is x equals, that's what we saw in the quick right, negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm going to go ahead and put that b in parentheses because when we take that b value and square it, we got to make sure that we put it in parentheses because if it's negative, it's going to mess us up. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It is a long formula. We will have it on your review, but that requires you to have your review with you on your test day. It's on your notes here as well. The easiest way to memorize it is to the tune of Pop Goes the Weasel. I'm going to pull it up because I don't want to sing it. It's something that, yes, you have it on your note sheet now, but if you need to use it on the ACT or the AccuPlacer or in a class where you don't get to use a review or a note sheet on your test, you're going to have it memorized. So this is the easiest way to memorize it. As I was saying it just now, I was saying it like to the tune of this in my head. So here is the quadratic formula to the tune of Pop Goes the Weasel. Okay, so that is how I learned the quadratic formula, probably 16 years ago, when I was a freshman in high school, and that's how I still remember it. So that's, I promise, the best way to memorize it. It's a little bit annoying, but that's what I think of as I'm writing it out. Okay, back to figuring out how to use the quadratic formula now. So we've got 5 steps because it's a kind of a long process of plugging things in and then working it out piece by piece. You can't just throw this one all in a calculator. So the first thing that we're going to do is we are going to rewrite the formula by substituting in our values for A, B, and C. So plugging in our values for A, B, and C. So let's actually come down to our first example and go ahead and do that first step on our first example. So down here we've got f of x equals 2x squared plus 9x plus 7. So that 2, 9, and 7 are my A, B, 9, and 7 are my A, B, and C values. 2, 9, and 7. to zoom and it's not on the right screen. Okay, so I'm going to rewrite our formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so my first step is to plug in my numbers. So B goes in two different places, A goes in two different places, C just goes in one place. But this step of getting the right numbers in the right place is imperative. So we've got X equals negative B is going to be negative 9 plus or minus the square root. So we've got this big long square root. B squared is going to be 9 squared minus 4 times my A value is 2 times my C value is 7. And then that all goes over 2A. So that's going to be 2 times 2 because my A value is 2. So that is step 1, is plugging in all 3 of my numbers in all of the places that they go. Excuse me. Any questions about step 1? Okay, moving back up to my list of steps then. Step 2, we are going to perform all of the operations and simplify out everything underneath the square root. So this is why we did yesterday's lesson yesterday, is we learned how to find the discriminant. That is going to be the next thing that we do, is actually work out the value of that discriminant of what's underneath the square root. So I am putting in my calculator only 9 squared minus 4 times 2 times 7. So it's just the stuff underneath the square root. So that is going to give me 9 squared minus 4 times 2 times 7. I can't read it from here. Yeah. Wonderful. Thank you. All right, so 9 squared minus 4 times 2 times 7. Hit enter. We get 25. So we just evaluated the value of the square root, or the value of everything underneath the square root. Any questions about that step? Okay, so we are going to rewrite everything. We'll keep our negative 9. We'll keep our plus or minus. And then instead of having the square root of all of this, we're going to put down the square root of just 25 because we've simplified that out. What's up? Yes. And then we are also going to go ahead and multiply out 2 by 2 on the bottom. At this point, 2 times 2 is just 4. I thought you said, what is that for? So that's our discriminant. All right, so negative 9 plus or minus has stayed the same. We did the 9 squared minus 4 times 2 times 7 to get the 25. And then we did 2 times 2 to get 4. Any questions right now? We'll run through this first one step by step. Okay, then we can go ahead and move back up to our list of steps and find our next step. Our next step is to find the value of the square root. What's the square root of 25? 5. So we now have, I'm going to rewrite everything except for instead of the square root of 25, I'm going to have the square root of 5. So I've got negative 9 plus or minus 5 over 4. I didn't mean the square root of 5, I meant just 5. So we've simplified out that square root. Okay, we are ready for step 4 now. These problems are all going to have 2 solutions because I told you we're going to have all positive discriminants, and a positive discriminant we learned yesterday when we did number of solutions has 2 solutions. How we are going to find the 2 solutions, because we're going to have 2 different solutions, is we're going to set up 2 fractions, set up both fractions. One's going to be the positive version, and one's going to be the negative version. Or sorry, one's going to be the plus version, one's going to be the minus version. That's the easier way to think about it. So right here, we've got negative 9 plus or minus 5 over 4. We're literally going to do negative 9 plus 5 over 4. And we're also going to do negative 9 minus 5 over 4. So when we say plus or minus, we literally mean we're going to do both. So we're going to set up those 2 fractions. I'm going to do 1 here and 1 here. So I'm going to have negative 9 plus 5 over 4. And then I'm also going to have negative 9 minus 5 over 4. So this is the point at which I split the plus or minus. Okay, and then from here, we need to simplify out both of our fractions. And so we have an example up here about simplifying. If I were to have 12 over 16, I can divide both 12 and 16 by 4. 12 divided by 4 would be 3, and 16 divided by 4 would be 4. So when we say simplify, we mean reduce, if we can. So we're going to do our addition and subtraction, and then reduce any fractions that we can reduce. Okay, so let's work out this top one. Negative 9 plus 5 is negative 4. So now I've got negative 4 divided by 4, which is just negative 1. For our bottom one, we have negative 9 minus 5. Negative 9 minus 5 is negative 14 over 4. We cannot divide 14 by 4. It's going to give us a decimal, and we want to leave things as an exact fraction. What can we divide both 14 and 4 by? 2. So if we divide the top by 2, we'll get negative 7. If we divide the bottom by 2, we'll get 2. So we get negative 7 halves, or negative 7 over 2. And those are our 2 answers. So negative 1 and negative 7 over 2 are our 2 answers. He's not here.
Okay, thank you.
All right, any questions right now? Okay, we are going to go ahead and flip this over. We've got one more to do together on the back, and then you guys will have lots of time to work. So this one, we'll get through a little bit faster because we're not going to go back and forth and back and forth and back and forth. Okay, so what is my A value in this problem? 3. Thank you, Sophie. Somebody else, what's my B value? -8. Thank you, Miles. And one last person, what's my C value? -3. Thank you. I have no idea who that was, but it was correct. Okay, so A, B, and C are 3, -8, and -3. For these problems, I always write, it's such a long formula, I always write down my formula with the letters first before I try to plug anything in. So I've got x equals -b plus or minus the square root of b squared minus 4ac all over 2a. This plus sign is awkward. Okay, so when we get started plugging these things in here, my formula has a -b, just like how -b over 2a had a -b. My b value in this problem is -8. So just like we did in 6.1, a negative becomes a positive. So -8 is +8 here at the beginning. Plus or minus, big hold long square root, b squared would be -8 squared minus 4 times 3 times -3 all over 2 times our a value is 3. Okay. Any questions about plugging things in? Okay, go ahead and throw that whole discriminant, this whole -8 squared minus 4 times 3 times -3 in your calculator. All right. So we'll see a few more people type it in their calculators. What did you guys get as your discriminant? 100. So that is what I got as well. -8 squared minus 4 times 3 times -3. I got 100. So I've got 8 plus or minus the square root of 100 all over, I'm going to go ahead and do 2 times 3, which is 6. Okay, what's the square root of 100? 10. Now would be a good time to point out that the square root of 100 is 10 or -10, but that's why I have this plus or minus here. So 8 plus or minus 10 over 6. And then this is the point at which I'm ready to split. So I can do 8 plus 10 over 6. And I can also do 8 minus 10 over 6. 8 plus 10 is 18. And 18 divided by 6 is 3. Eight minus 10 is negative 2, still over 6. What can I divide 2 and 6 both by? What can I divide them by? 2. So if I divide by 2 on top and bottom, I'll get negative 2 divided by 2 is negative 1. 6 divided by 2 is 3. That's where you were getting that 3 you were thinking of. So I get negative 1/3. So my zeros are positive 3 and negative 1/3. A few things that you guys will notice today as you go through your examples. For today in Algebra 1, all of your discriminants should be perfect squares. So right here we did square root of 100, we did square root of 25, so you'll get things like square root of 36, square root of 49, square root of 64. So they will all be perfect squares. In life, not everything that you do the quadratic formula for will be a perfect square. In Algebra 1, we are only dealing with perfect squares. Another thing that you guys will notice is that you will tend to get at least one fraction here, if not two fractions. The reason why is if these were both whole numbers, it would have been easier to factor this, and we would have just factored it. So that's why problems that we use the quadratic formula for, we can use them for any problems. The problems that we have to use the quadratic formula for always are going to give you at least one fractional answer. Any questions right now? Yes, I will flip up to there. Anybody need any of this on the back still? Okay, I'll flip back in a second. I'm going to stop this recording.